Hello, my name is Matthew McKnight. I am a programming mentor for Team 4536, and this is the first in a series of videos to help you program better. This it focuses on DriveSystem. We're going to create a sample simplistic DriveSystem to show you some of the processes that we use. And this particular video is going to focus on three main things: the instantiation code, or the code that is used to create a class; the parameters that can be passed into a method, including in this case the instantiation method; and the use of private variables, class level variables, to help aid in encapsulation. So let's dive in. I have created a branch called DriveSystem MN because I know better than to work directly on the master. And I'm going to start working on it and demonstrate some of the fundamental aspects of programming, primarily around a drive system, so you can see how that would work. One of the things I want to highlight here is encapsulation. So if you watch the separation of concerns video, you understand that encapsulation is building a strong wall around your object to protect it from people getting in and breaking it by accident. One of the ways to do that is to have certain objects inside, or certain variables inside that are private, and only expose them if you wish to in part. And what will happen here in this case is we're going to create or instantiate a drive system by accepting a set of parameters which are going to be the actual motors. Once we accept them into our system, into our drive system, we're going to lock them away so nobody can access them except us. So as we go forward, I'll explain how that happens, and this is a means to keep our code safe. So I'm going to go into Subsystem, create a new Java class, and I'm going to call it DriveSystem. That makes sense to me. And I hit enter, and then we have the drive system. Note it's a public class, which means anyone can see it. And up at the top, if you see the first line, it says package org.firstinspires.ftc.team4536.subsystem. That is because that is the folder in which it is located. If you were to drill down through the folders, those would be the folders you would follow, and you would end up in subsystem. As you can see, that is where it's located, subsystems. That's why it's in that package. Not all languages are that picky, but Java is very particular about where you put your files and therefore what package they belong to. So that's what a package is. It's simply the collections of folders in that, or collection of files in that folder. All right, two things that all classes have. It has methods and it has properties. Before I continue, if you're new to programming, you may be wondering what these two forward slashes are. Those are remark lines. So if I put two forward slashes in front of a line, I'm commenting it out. This is only for humans. Computers don't care about it. They'll totally ignore that. So this is a human-only thing. You can do the two double slash, or if you have a longer set of code or text that you want to put in there, you could do the / asterisk. So that's what that is. So again, going back, there are two things that all classes have. They have methods and they have properties. Methods, if you want to understand that, is what a class does, and property is what a class has. So method does, property has. Kind of strange to wrap your brain around. So let's use an example. Let's say you have a cat object. The cat object has the method of meow. That's what it does. On the other hand, it also has the property of whisker. Whisker is not a method. It doesn't do a whisker. It has a whisker. It does a meow. It doesn't have a meow. So the cat object here has both a method and a property. Just in the same way as this drive system will have methods and properties. One good example of this is that the drive system will have properties of its motors. It needs its motors to actually function. And it will have a method, say, set power, to set power to those motors. So it has drive motors, and it does the setting of the power to those motors. And let's wipe this out and move forward. Now, it may look, if you looked at drive system right now, you might think, right now it has no methods and no properties. And it would seem true, but it's not. every class has a default method. That default method is a special method. It's called the instantiation or the creation method. Even though you can't see it, it's here. If you could see it, this is what it would look like. Public DriveSystem, parens, curly brackets. What this means is that if you create a new DriveSystem, and new is the word that we use to instantiate a new object. If you were to create a new DriveSystem, that DriveSystem would exist because of this default instantiation class. It wouldn't have anything in it. It wouldn't have any other methods or any properties. But if you were to create a new DriveSystem, it could exist. It'd be very boring, but it could exist. So for example, if we type DriveSystem, and then we give that variable a name. So if we declare the type of the variable in the first word, we give it a name with the second word, DriveSystem. This time we go lowercase, that's an arbitrary name, equals new DriveSystem. So DriveSystem equals new DriveSystem. What we said is we are going to create an object of the class DriveSystem. We're going to call it small d DriveSystem. And then we're going to create it by calling this instantiation method, new DriveSystem. So as we go forward, that'll make more sense if it doesn't make sense right now, but just see that this is the process. We're calling upon the default instantiation method. Instantiation methods are special. They return back the object, which is the class they're found in. We can use that to our advantage. There are many ways to pass parameters in and out of classes, but one of the main ways is to do it through the instantiation method itself. In other words, we're going to use the instantiation method to gather from the outside the motors that we need, and then we're going to wrap them and protect them within our class so that only we have access to that. So that may seem kind of like a strange idea, but it's very important and very common, and we're going to do it now so you can see how it works. So what are some of the properties we're going to need for sure in the DriveSystem? Well, the DriveSystem is going to need motors. That's because we're an FTC. So we're going to create a private variable of type DC motor. Notice, by the way, the DC motor is bright red. That's because we do not know what it is yet. Leverage our IDE to do that. But for now, I'm just going to call it M underscore drive motor right front. Now, notice the variable name. M underscore means that it's a class variable. It's going to be global throughout this class. Drive motor right front. The first letter is lowercase in the words, and other than that, it goes onward. So drive is small, motor, right, and front are all capitalized. When you name a variable, you just need to have an agreed upon convention. So we use M underscore as our class variables, actually member variables. And this way, when you see it somewhere in the code, you know that it is a global variable and not something else, because variables exist within what is called scope. So they exist for a certain period of time within a certain area. Global variables, those who start with M underscore, exist within the entire class. When you create the class, they are created, and when you destroy the class, they are destroyed along with it. But other than that, they exist within the class everywhere in every method. Unlike, for example, a variable that's created in a method, that would only exist within the scope of the method. A variable that is created in a for loop would only exist within the scope of the for loop. So we'll talk about scope more in another place, but as you'll notice, it's at Qualcomm robotcar hardware.dc motor. That's the package. Remember, packages are things that aren't yours that you import. So let's say you're working on your house, you need some screwdrivers, you don't have any, you go to Bob, your next door neighbor, you say, Bob, can I borrow some screwdrivers? He gives you the screwdrivers, and you take it with you into your house to do the work on your house. Now, you've imported Bob's screwdrivers. They aren't yours. You're going to import them, and then you're going to use them. The same way, we're actually going to import DC motor. If you hit Alt-Enter, you can choose Import Class. You see that top choice? And what it will do is it will add an import statement to the top of this file. There it is. Import com.qualcomm.robotcore.hardware.dc motor. And what that does is it enables us to now use DC motor within our code. They've written all the code that is around DC motor. We're just taking advantage of that, so we don't have to write that code. So we have one variable, private DC motor, M drive motor right front. We're actually going to have 3 more that we're going to come up with, and they're going to be done exactly the same way. And all of them will use this import statement to help us understand what we can do with DC motor. So import is a way to sort of take chunks of code from someone else and leverage them within your own job. All right, I want to emphasize again that the DC motor is private. So it's a private variable. It's a variable of type DC motor, and we have assigned it the arbitrary name of M underscore drive motor right front. That's what that line says. We're going to create another DC motor, also private. This one we're going to call M underscore drive motor right rear. In case you haven't noticed, I have no problem with long variable names. Private DC motor. Can you guess when the next one's going to be? By the way, if you hit tab, it'll auto-fill it for you. You're gonna get used to hitting tab a lot because it speeds up your typing ability. M drive motor left front. I like variable names that when I look at them, they tell me what the variable is about without me having to dig through the context where I find the variable. That can be frustrating and a little confusing. There was a time when somebody was using a server both as an object and as a Boolean, which is a huge no-no. And it took me a while to wrap my brain around the fact that they actually had used the same variable name, although it was in different scopes, that they'd used the same variable name in 2 different ways. So long names are great because they let you look at the variable and know what it is. Now, here's the problem. We need these 4 DC motors, but we have no ability to create them. We need to have that given to us from outside. And one of the ways, if you saw my separations of concern video, is that you can get objects and parameters in the parens in the instantiation of your object. So public DriveSystem parens, and then the square brackets. We're going to put things between those parens to allow people to pass us in what we need. What we need are 4 DC motors. So parameters are those things passed into methods to enable them to accomplish their task. They could be objects, in this case, the DC motors that we're going to need. They could also be things like an integer, let's say the number of people on a basketball team, or a decimal, the weight that I am. They could be a true-false parameter. All of these things are passed into methods to enable the method to do its job. They're the parameters that the method itself has to work with, if that makes sense. Parameters can be of a variety of types, all passed in, so you don't have to pass just one type as a parameter. You could pass a Boolean, an integer, an object, a cat object in the as parameters between the parentheses, and the method will take them in and it will use them. So what I'm going to do here is I'm actually going to require that when they instantiate this DriveSystem, when they instantiate this class, that part of that is they're going to have to hand me over 4 DC motors that I can use for the right front, right rear, left rear. One thing to note as well is, as I mentioned before, there is the default instantiation code. It basically creates an empty class. When you create an instantiation code, which is what I'm about to do, that default instantiation code goes away. If you want to have it as well, because you can have multiple instantiation codes for a class, multiple ways to create a class, you actually have to redeclare it separately to use it. All right, so we're going to actually start entering in the parameters that we're going to want. We're going to want a DC motor, and I'm just going to give it the name drive motor right rear. What these do, these names that I'm putting in here, they expose to the person that is calling the method what the variable is that they want put in. And since I'm putting in 4 DC motors, I want to have each DC motor have a unique name. So they know I'm doing the right front, right rear, left front, left rear, and they put them in the order they need to be. So I'm just showing you right now, if I do the drive motor right front, this is how I assign it to the private variable. Within the instantiation code, I'm going to actually assign to M underscore drive motor right front the parameter that got passed in, the DC motor that got passed in. And by doing so, I'm taking it and I'm sort of putting a shield around it at this point. This motor is now one that I have that I'm going to use, and the only way that anyone is going to be able to access any of its properties or do anything with it is if I open up another door in. So I've taken this parameter that's been passed in and I've made it a private variable, a private class variable, and I'm going to do the same thing with the next three motors. So I'm going to do another parameter called DC motor. I'm going to call it drive motor right rear. I need another DC motor, drive motor not right, but left front, and then DC motor, drive motor left rear. And by putting these names in there, when people are instantiating the DriveSystem class, they'll know the order in which they should put the drive motors or the DC motors into the instantiation call. So just like I did with the m_drive motor right front, I'm now going to assign the next three of them to these private variables that I have created. So this is a very common thing to do in code, is when parameters or especially objects are passed in, to assign them to class level variables, for example, so that they can be used throughout this class, but I am protecting them from being messed with from outside. So I'm completed here. I've actually assigned these four parameters that were passed in the instantiation call to private variables. And as we go forward, you'll see how I can use these new private class level variables in code. So this is the way to create the default structure for your DriveSystem instantiation. And like I said, at this point, if somebody wants to instantiate or create a DriveSystem object, they will have to pass in 4 DC motors. There is no other instantiation method that is created at this point. If I wanted to enable them to create an empty DriveSystem with no DC motors, then I would actually write an additional piece of code below, which would simply be public DriveSystem, open close param, open close squigglies, which would then enable me to have a second possible way to instantiate. But I don't want that. I want this single instantiation call because I want to receive all 4 motors so I can work with them. Now I've got them in here, and you've seen that I've assigned the private class variable to them. And now the next step is I'm going to actually initialize them in this code. So they could have been initialized outside of this code, but in my mind that doesn't make sense. This is the code that handles them, and so in the next video we're going to start the process of initializing and setting these up the way we want them to be. So I will talk with you in the next video.